welcome to the session. So in this particular video, I will be talking about the DSA roadmap. I know that many students have requested me towards creating this particular video, and many of you are waiting for this as well. So let's get started, and today we are going to discuss what personally I feel that should be the roadmap for data structure and algorithms, right? So whenever you are starting this DSA journey, first of all, I want to give you one tip that never ever compare this particular journey with any other student or with anyone. People usually start this journey and they will get demotivated by comparing this with others. Very number one step, right? Now, what are the things that you should take care of whenever you are starting this particular DSA? First of all, you should be very good with the programming fundamentals. By saying that, you should know at least one programming language. It doesn't matter whatsoever programming language you're comfortable with, but at least one programming language you should be expert at, right? Now, apart from that, whenever you're going for an interview, you also should have an idea about DBMS, database management system. You also have a good idea about operating system, computer networks. These are the fundamentals of computer science, I believe. So everyone should have the basic understanding of all those things as well, right? Now, whenever we are talking about specifically DSA, so in DSA, you should always start with the core concepts, right? Where we will talk about the analysis part. In analysis part or in analysis module, usually I specify that I usually categorize it as an analysis module because here in this module, you should know about the importance of time and space complexity. You should know the importance of recurrence relation and how we can solve any recurrence relation. So you should know the recurrence relation solving method. So this is the, I would say, the core of data structure and algorithms, where you usually learn about mainly three methods. It's substitution, Master's theorem, and the recursive tree approach, right? So in this module, you should basically deal with the a priori analysis. So usually people also don't know what is the meaning of that. So a priori analysis meaning that we are dealing with approximations here. That's why we usually talk about big O, omega, and theta based time complexities, right? So this is the basic idea from where we should you should get started, right? After understanding of the analysis module, you should start with the data structure named array, where the core concept lies, array and I would say strings. So you should know about this data structures. Here, when I'm talking about this data structure, by saying that, I would say maximum companies will simply ask you the basic questions of these arrays and strings. Why? Because whenever we are talking about DSA, how DSA is helpful. Many people used to ask to me that, okay, if I am a data scientist, if I am a machine learning expert, why the interviewer is asking to me in the first round about the data structure algorithm? I don't even use that in the industry. No, it's not like that. You are from any of the background. DSA basically helps us or helps the interviewer to understand about your problem solving logic, problem solving skills. So in a way, suppose there is someone who is very good in designing the website. If suppose he don't know about the concept of time and space complexity, then he won't be able to optimize the code pretty well. And maybe he will be able to design the website, but when more users will come into that website, the website will crash. Why? Because he don't know the optimization of that. So basically, wherever the optimization is required, DSA will always come into picture, right? So by solving these different kind of questions, by solving these different kind of algorithms, we are in a way train our mind to enhance our problem solving skill. That's the only concept behind the DSA, I would say. So in arrays and strings, there are very famous questions. For example, there is one question which is based on 2 pointers, right? So questions are same, the concepts are same, but the variety of questions are always there. And you might, if you first of all able to understand the concepts, then variety of questions are so many. So more you practice, more you will get comfortable with all those questions. For example, there is a concept of cadence algorithm, right? So these are the kinds of concepts which are very much important, right? So in specifically talking about arrays and strings, again, in arrays also you will be having one-dimensional array, and then you also have a 2D array concept or multi-dimensional array concept. In that concept also, we will be having so many matrix computations, right? They can talk about matrix multiplication. They can talk about the transpose of a matrix. So all those tasks we can have or we can come across in our interviews with respect to the 2D arrays. So this is the very first topic after the analysis module, after understanding of analysis module, you should go with arrays and the strings. And even you will observe in maximum very good companies also, specifically in very good startups, they just ask about these questions only, which is totally based on arrays and strings, because they want to just check the problem solving skill of yours, which can easily be determined if someone is good with these questions only. Now, to practice these questions, there are so many platforms that we have, and every platform is really good. You can either check with Lead Code, you can go with Geeks for Geeks, you can go with Coding Ninjas. I don't know, there are so many platforms we have, but personally, what platform I usually like? I like the Lead Code platform. That's my personal opinion. You can go, you can see, and after that you can decide according to your own needs which platform suits you the best. Okay. So here, this is the thing that we have. After completion of this particular portion of arrays and strings, you should get started with the concept of recursion. Now, recursion is something which is very, very important, I would say, whenever we will be talking about data structure and algorithms. It's a very beautiful concept. Initially, students feel very much difficulty in terms of understanding the concept of recursion. But once they understand that concept, they really enjoy that. Why? Because maximum questions we will be able to solve just by creating a recursive call, just by creating that recurrence relation, right? Just by creating that calling of the same function again directly inside the method definition. This is what we call as recursion, right? So inside recursion, there are some, first of all, basic questions of recursion that you should understand. So always whenever you are starting any new topic, always start from basic things and then step by step reach towards the advanced things. In this way, you will never lose the motivation to study something new, right? This is how I used to approach towards any of the new concept. I always start from the basic thing, and then I'll spend some most of the time towards dealing with that particular problem. I practice a lot of questions, and then only I will be able to grasp that concept, right? Nothing is magic here, right? So we have to start from the basic. Once you're done with the basic questions, then go with the divide and conquer. So in this particular divide and conquer approach or module, so this is a very first module which I used to start in our algorithms part. So this particular algorithms says that whenever the problem is big, divide the problem into various sub-halves, create various sub-problems, and then try to conquer it step by step, right? So all the applications that you will see so far with respect to divide and conquer, all are only solvable if you know the concept of recursion. So all the applications of recursions, I would say, are same as the applications of divide and conquer. For example, you must be familiar with the concept of merge sort. You must be familiar with the concept of quick sort. You must be familiar with the concept of searching algorithm like binary search, right? So these are the various very good applications of the recursion. In the basic questions, I can talk about finding of factorial. I can talk about maybe the Fibonacci series, something like that, right? So here, first of all, you need to understand the basic questions, where how basically recursive tree will be created, how recursion will happen, right? How basically function calls will be stored inside the stack data structure, everything you should know. After that, go towards the divide and conquer module, where you will see a lot of applications which are directly solvable with the help of this recursion concept. Even recursion you will see when we are talking about dynamic programming, it's an advanced version of recursion only. So I can say that recursion is one of the most important topic when we are talking about a data structure algorithms thing. So please study this particular topic very much beautifully, very much carefully, very much consciously, and spend a lot of time while doing the questions, not only just to get the solution out of that question, but spend internally that how basically recursive tree is created, how basically the recurrence relation is created. You should know the internal depth of that particular recursion code. Okay. After that, after dealing with that, so you should also, then you can come towards the sorting algorithms, where we do have different kinds of sorting algorithms. Broadly speaking, we will be having two classes. One is called as comparison sort. Fine. And the another one is something which we called as known comparison sorting algorithms. Usually, known comparison sorting algorithms are not that much frequently asked, and the comparison sorting algorithms are the ones which are asked frequently. Here comes like the selection sort, here comes like the bubble sort, right? Here comes like the insertion sort, here comes the quick sort and the merge sort, which I already have written in the above part. Here comes the shell sort. So these are the comparison based sorting algorithms. Heap sort, right? When we talk about known comparison sort, means here the elements are not comparing within itself, like the count sort, like the radix sort, right, the bucket sort. So these things will come into picture, but you should be aware about that. So all these sorting algorithms will come into picture once you are done with the concept of the recursion. After completion of this sorting algorithm completely in very much depth with its implementation, you can start with the searching algorithms. Now, in searching algorithms, if you will see, we will be having mainly two different types. One is called linear search, where we are searching an element linearly. Another one is something which we called as binary search. Now, this binary search is something which is really, really important. This is the very vastly asked question in many of the interviews, because there are a lot of applications which you can solve using the help of a binary search algorithm, right? Because in linear search, we are getting the complexity as big O of n to search any element. The same thing binary search is doing with the help of big O of log of n time complexity. Now, which one is greater, which one is smaller? All these things you already are aware of because you are done with the analysis module, and that's the importance of analysis module, where you will be dealing in a priori analysis about the complexity classes inside that. So you will be easily able to get an idea that what is the complexity which is very high, what is the complexity which will be very low. All these things you have already understood. So when you will reach towards the searching algorithm, you will see that this binary search contains a lot of applications, and there are so many questions which can be asked from you with respect to arrays and with respect to the metrics. For example, whenever a sorted array is given to you, or sorted matrix is given to you in the form of a rows or in the form of a columns, do think that whether you can apply a binary search on top of that or not. Because in 99% of the cases, I would say, maximum questions will be solved using binary search. They always provide you a hint by telling you that a sorted array is given to you, right? And binary search is applicable only for the sorted arrays. Why is that so? What's the logic behind that? I already clearly have explained on my YouTube channel, right? So I will not repeat those things again and again, but yes, this is the key thing that you should understand. One of the most important topic in our series of DSA, right? After that, once you're done with the searching algorithm as well, so until now, we have done with only one data structure which I have talked about, which is arrays and strings. I haven't until now touched upon other data structures, because this divide and conquer, the sorting algorithms, the searching algorithms, you will be able to understand if you have an idea about the arrays and strings in much depth. After that, it's the time to talk about another data structures that we have. For example, you can after that start with a linked list. Now again, linked list is a wonderful data structure which has a lot of applications. kind of questions which you will face in an interview is like very famous. Still now it is usually asked. For example, reversal of a linked list. For example, finding of cycle detection algorithm. So finding of cycle in a linked list. Finding of cycle, or it is also famous by the name of cycle detection algorithm. So given a linked list, is there a cycle which exists inside that linked list or not? So this is something which is cycle detection algorithm. Apart from that, so here in this particular cycle detection, there comes a concept of fast pointer and slow pointer. Now, once you understand this concept of fast pointer and slow pointer, the same concept is valid for many of the different varieties of problems. That's why I am saying that you should need to understand the different varieties of concepts, because questions are too many. So once you will be able to understand the concepts, your mind will be able to get an idea that, okay, this concept, can I apply to this question or not, right? Now, if suppose you don't know the concept, or if you're not aware about all these concepts, then for sure, if you will think that while sitting in an interview and somewhere you will be able to get an idea that you can apply those concepts, it will never happen. So you usually have an idea about these concepts. Yes, if we will give you the variety of that concept question, then you will be able to get an idea that, okay, can I apply that? There is a chance that that particular concept is applicable to that question as well, right? So apart from that, whatsoever sorting algorithms we have talked about in the above part, those sorting algorithms also can we apply here, and if yes, how we can do that with the help of a linked list. Apart from that, they can also talk about the modification of a linked list. So can you modify the data inside the linked list? Means, can you do the addition? Can you do the insertion? Can you do the removal of the linked list? So modification inside the linked list can also come into picture. Now all these questions, whichever I am talking about here, can be asked. There are a lot of variety of questions apart from that as well, but these are the kind of a variety of questions which usually people faced, right, in a very good companies also. So if you will see here, again, these questions are just checking your problem solving skill. Reversal clearly checks that how basically you are good with pointers, how you can point the nodes in such a way that your list will get reversed. So they just want to see the internal implementation of all those things, right? After getting the linked list concept pretty well, you can start with the concept of stack and queue data structure, right? Where now here it's not about that you just know it is LIFO and it simply implements FIFO, where LIFO means last in first out and FIFO means first in first out. It's not like that. You should know at least the pseudocode of the same. So when I'm talking about pseudocode, you should know for every particular thing. But what usually happens is that whenever we used to do the coding in Python programming language, specifically I'm talking about, one good thing which I liked about that programming language is that it is very user friendly. Means we have the packages, we have the libraries, we have the functions, we can directly call them and our task is done. But by saying that, the major factor which is I found it as a disadvantage is that there is a lot of abstraction layer there. Means if suppose student is not interested in knowing the things internally, he will not get an idea, right? He might be able to get the output, but he will not able to get the idea that how internally things are working. But when he moves towards a technical interview, interviewer will definitely ask to him, can you tell me the internal implementation of the same? Can you tell me the logic behind the internal implementation? At that point of time, he will face the trouble. At that point of time, he will face the issue. So that's why whenever you are learning stack and queue, yes, there are directly in Python, you can import dq, right? You can call the stack in terms of, you can implement that in terms of arrays, using the arrays and using the linked list. It's completely fine. I'm not saying that it's wrong to directly import the libraries and the packages. Yes, it's for us benefit only. But by saying that, what I'm saying is that you should know the internal concept and the implementation of the same. So if suppose interviewer is saying to you that I don't want to directly use the libraries and the packages, which are already available. I want you to create a class and create your own functions inside that. You should have the ability to implement that stack data structure on your own by saying LIFO kind of architecture, by saying when I'm talking about queue, FIFO kind of architecture. So you should do the internal concept and the implementation for the same. So this is about the stack and queues. Once you are done with this data structure, after that, here comes a data structure which is completely based on tree-based data structure. Inside trees, you should have a good understanding of the binary tree, right? Where you should understand what is the meaning of complete binary tree, what is the meaning of full binary tree, what is the meaning of almost complete binary tree, what are the different questions which can be asked with respect to binary trees. Usually they are talking about the views, like top view, can you able to print, bottom view, can you able to print with respect to a binary tree. So views of the trees, right? You should know. You should know about the tree traversal algorithms inside that, which we have, maybe in order, post order, pre-order. So these are the three different kinds of algorithms that we have inside the tree traversal. What is the recurrence relation of that? How will you implement those tree traversal algorithms? Apart from that, what is level order traversal? That also you should know. That level wise, how basically we will be able to print the data inside the tree. Usually people know what is pre-order, what is post-order, what is in order, but they don't know the implementation of level order traversal. So that also you should know, right? Apart from that, the same thing you should know about BST. And what are the important properties of BST that we have, and how this BST you can correlate with the traversal. For example, if you will do the in-order traversal of this BST, so this is the important property that you should know, that if you do the in-order traversal of the binary search tree, you will be able to get a sorted array. So these kind of things you should be aware of, because that will again, these concepts will again help you to solve any interview based question where you think that this particular concept you can implement, right? So you should aware about the tree based data structure. Now when I'm talking about tree, or after the tree, which whatever I'm writing here, these concepts are something which came under the advanced category. Until this part, when I'm talking about the stack and queue, this is the preliminary thing that you should know whenever you're going for any interview. Now, if suppose your target is to crack a tier 2 or tier 3 company, I think you will be easily able to crack if you know these things also. By saying that, yes, companies might ask other concepts which I will write below, but at least start from there and complete until the stack and queue part. After that, go for this tree-based data structure. Don't start directly with the trees. After that, what you can do is that here comes again a very important concept of graphs. Now in graphs, obviously you should know, first of all, majorly you should know what is BFT, breadth first traversal, and what is DFT. Once you're able to get an idea what is this BFT and DFT, which are the two famous traversal algorithms inside the graph, after that you will be easily able to, do a lot of questions which is totally on the basis of BFT and DFT. For example, one question which I was talking about is level order traversal, a very famous question. Inside that only they can just do a manipulation, or they will modify the question and they will ask something from that. So all the networking which in real life also usually happen is already done with the help of a graph based data structure. Now once you are done with this particular data structure, here comes the concept of dynamic programming as well. Now this DP, graph and DP are very frequently asked in, I would say, Google based company, Directy company. So in these two companies, at least whatever experience I have, dynamic programming is usually asked in a technical interview. So now when I'm talking about dynamic programming, it is nothing but it's an advanced version of recursion, I can say. But people usually think that it's not the case. But what I think is that it's the case. So it is nothing but it's an advanced version of recursion. So if you know the concept of recursion pretty well, then only you will be good with DP. Because any of the question given to you, first of all, you have to think, your mindset should be that how can I solve this question using the recursion? So there are mainly two approaches which we have to solve a dynamic programming. One is called memoization, right? Inside memoization, which is a top-down approach, you will use the concept of recursion and you will try to solve the problem of overlapping subproblem using this concept, right? Apart from that, there is another approach which we call as tabulation or a bottom-up approach. So it's an advanced version of recursion where suppose the key questions are like longest common subsequence, like sum of subset problem. So there are so many problems which in using divide and conquer, you might face a TLE kind of issue, time limit exceeded, and that kind of issues will be resolved using the dynamic programming. That's where DP will come into picture. So this is the concept of DP. So this graphs and DP, whatever I am saying, these two parts, the graph and DP, I would say these are the very important topic if you want to crack something like Google, if you want to go for Facebook. So at that point of time, I will definitely recommend to you that do these two topics pretty well, because these topics can be asked from you. It's not mandatory they will ask, but 99% of the cases, these questions, whatsoever, because there are so many friends of mine who are in these companies. So I also gave the interview to these companies. So these questions I have also faced. So dynamic programming and graph, please be very good with that. For example, the shortest path to find, to reach to the target, all these questions, how you can do. So here again requires a good problem solving logic, which you can do with the help of a graph based question. Any kind of networking, if they are talking about, you can solve with the help of this graph based data structure only. Now, after covering up these things, these are something which I will categorize as the most important things, most important topics, right? Starting from analysis until reaching towards the dynamic programming. Apart from that, if you still have the time, then you can go and explore towards the hashing data structure in depth, right? Hashing data structure. After that, there is something called as trie, right? This is another data structure which you should be aware of. But what I'm saying, I'm giving you the sequence. So once you're done with stack and queue, you can clearly apply for tier 2, tier 3 based companies. Most probably you will be able to crack that, because maximum number of times their questions will be based on recursion or arrays and strings, right? After that, linked list, stacks and queues. After that, if you're moving towards the tier 1, you should have a good grasp over trees, graphs and dynamic programming. After that also, what other topics that you should cover up if you have the time, that is hashing data structure, trie. There is something which we called as greedy algorithm. What are the applications of that? This is also pretty much important. Here comes a lot of good applications which can be asked, which is basically Dijkstra's algorithm, right? Minimum spanning tree, DIJK, shortest path finding, and then Dijkstra's algorithm, minimum spanning tree, MST. So these are the few topics. Again, they can ask you about the implementation of the same. This is on another level which you should be aware about if you are going for a Google based type of companies, right? So greedy algorithms are the ones. Apart from that, there is something which we have in the linked list called as circular queues. You should be aware of, right? Apart from that, there is something which we have called as skip list. You should be aware of, right? These are the concepts which can come under the advanced data structure algorithms. After that, there is something which we have as DQ. You should be aware of, right? There is one thing which I missed here is you should also know the concept of heap data structure. It's also a very frequently asked questions, and nowadays a lot of questions are asked in this heap data structure. I have created one video also specifically for this, which is uploaded on Krish sir's YouTube channel in the playlist, which is about, I think, 2 hours long. There I have clearly explained the concept of heap data structure. Again, its application. Whenever you are seeing something in a question, finding out k frequent elements, finding out k closest elements from the origin, these kind of questions can be done in an optimized manner when you are using a heap based data structure, right? How internally it is working, everything in depth I have clearly explained. This is again a really important topic whenever you're going for an interview. Okay, apart from that, this DQ is done. Apart from that, I think there is something which we have, a string based algorithms, string matching algorithms I should say, where we will be having the KMP algorithms, right? So all these algorithms, whatsoever we have, you can have a good grip over that. After that, other than that, there is something which we have called bit manipulation, where we usually study that how basically we can do left shift, right shift. What will be the importance of doing a left shift or right shift? For example, if you do the left shift, there is a exponential increase in the power, meaning that you are increasing the number by power of 2, which means multiply by 2. For example, you will be having 2. When you do the left shift by 1, you will get 4. When you do the left shift by 1, you will get 8 into 2. Similarly, for right shift, you will be getting a division by 2. So all these things you will be able to understand when you are done with this concept of bit manipulation, which will mainly help you in terms of mathematics kind of questions in DSA while solving that. So, and in lot of competitive programming, if you are really interested in doing the competitive programming problems, so in that particular case also, it's very important for you to have a good command over this bit manipulation topic, right? Apart from that, I think I have covered up almost everything. Let me have a check once. Circular queues, doubly linked list is also included here. Doubly linked list, circular queue, circular linked list. So these topics are the ones which you can take as a third priority. So basically, you can start with the priority number 1. After done with the priority number 1, you can go with the priority number 2. And after that, you can complete this particular part as well. Usually, if you are consistent, you can complete all these things within 6 months at max. I'm saying with the proper practice from any of the platform. But the only key thing is that you should be consistent. So here, the more you solve the problems after understanding of all those things, you will be able to get the concepts pretty well. Here, in the third category, I can also write something called as backtracking kind of problems, which can also come. Backtracking, which is usually done in using a recursion concept only. So here, if you will see the key of all of the topics which I am writing here, a lot of times I am saying only the one word, which is recursion. So when we are dealing with a recursion, or whenever you are starting with a recursion, please highlight this as the important topic and understand each and everything with respect to this recursion pretty well. This will really help you a lot in understanding of lot of concepts related to DSA, right? So this is the overall roadmap which I feel is pretty much important and everyone should follow in order to have a good command over this data structure algorithms, and which actually industry requires, or which is actually helpful to crack any of the good product based companies, right? So you should always start from a scratch. One key thing which you should take from this session, always whenever you're learning any concept, start from scratch, do it step by step and be consistent, right? Second thing, which key number 2 is that whenever you are preparing this, give at least 6 months to yourself, and within those 6 months, never ever compare your journey with any other student, right? Even don't talk to anyone, I would say. Be very much focused on your task, give yourself 6 months, practice a lot, spend more time, and you will be able to get a good confidence over this data structure and algorithms part, right? That is the key number 2 which I want to give to everyone. Key number 3 for this particular roadmap, once you are done with all these topics, usually what happened is that suppose we are learning arrays data structure. After that, we are practicing the questions based on arrays, maybe on any of the platform, you are doing so. Now, suppose you did divide and conquer, you are practicing the recursion based problems. Once you are done with the complete syllabus, take random 50 to 70 questions and do it randomly. Now you don't know that what data structure you should apply. This is a kind of a thing which will happening in the interview. So it's now there comes a actual test of yours, that whether you will be able to understand that which particular data structure you should go for to implement this problem. Which one is the optimized data structure? Which one is the optimized algorithm to solve that? So try to do this practice to at least 50 to 70 questions in order to have a check. Now in that check, you might face difficulty in the initial questions. Don't think like that you don't know the topics. You know the topics, it's just that now you are practicing your mind in some different way. In some actual reality way, where you are going for an interview, obviously they will not say to you that, okay, solve this question using arrays, solve this question using DP. It's your job to determine that which data structure you should use. It's your job to determine which particular algorithm I should use there, right? So for that particular thing, you have to give a proper hit and trial method before the interview. You can just pick up 50-70 questions where you don't have any actual idea that what is the array data, what is the data structure they are using, what is the algorithm they are using, and how they are solving that. Think over it on your own, because now you have a good command over all the algorithms. You have a good command over all the other data structures. So now you are good to go, right? So this is the way to study. This is the overall roadmap. Again, I am saying this is my personal experience according to which I am sharing with you all. If you feel there is something which is missing, if you feel there is something which we can add more, or if you feel there is something which we can delete, so do let me know in the comment section. I'll see your comments for sure. And with this, I would like to end this particular video. Bye-bye everyone. Happy learning to all.